This is spectrum analyzer 500 megahertz. The spectrum goes from 10 megahertz to 550 megahertz and displays the center frequency with the help of coarse and fine pots. Here the center frequency is being displayed with the accuracy of 100 kilohertz. The sweep width, that is the scan width of the signal, can be changed to magnify the signal. Then there is a marker which can be switched on and which can be changed from 10 megahertz to 550 megahertz with the help of this variable tune pot. The moment we switch on marker, the marker LED glows, and when the marker LED is off, the center LED is glowing and the displayed frequency is center frequency. If marker is switched on, then the frequency displayed is of marker. Then there is RF input, which is a 50 ohm BNC input. There is a video filter which will remove all the spurious signals and give a filtered output, filtered input to the spectrum of any signal being fed. Now this spectrum has got X and Y output, horizontal and vertical Y. This is a CRO. Any CRO can be used. CRO is not a standard part of equipment of spectrum analyzer. Can be used taken from a lab. Now here in this CRO display, what we have done is we have clicked display and select the format as XY. When you select the format as XY and persistence, if persistence is off normally, you can set the persistence to 1 second for better display, which is not required in analog CRT CROs. And set the dot. A dot will appear. This is the dot. If you can see, the dot can be moved. Now this dot can be put in this position here. That is just at the bottom of the CRO, and set the channel 1 and channel 2 volts per division at 500 millivolts per division. Now use ordinary cables. These are ordinary XY cables which don't have a frequency response. So these are to be used only in XY but never for RF input. Now this horizontal, when it is connected to X channel, a horizontal line is appearing, and when you connect channel 2 to vertical, the display is being increased vertically. Now set the sweep width to minimum, or rather maximum, so that what you are displaying, the center frequency, if it is 280, this is 0 and this is 550. Now in order to better view, what we will do is we will remove and this is where the spectrum is being set. Now the center frequency, now it is showing an entire frequency range of less than 10 megahertz, rather 1 megahertz to 550 megahertz. Now the signal can be enhanced with the help of this sweep control pot, and the center frequency is being displayed. Now the displayed frequency is the center of this CRO. So now what we will do is we will use a signal source. Say the signal source is at 550 megahertz, and we will connect it here. This is the RG58 low loss cable. Only these cables should be used, otherwise the spectrum will start picking up a lot of noises, because a leaky cable will start act as an antenna itself. So specialized cable needs to be used. This is a very low loss, highly shielded cable. Now as you can see, the signal input fed from a signal source is around -57 dBm. So the display is showing around -57 dBm here at 550 megahertz. Now in order to view this signal, bring the center frequency to 550 megahertz with sweep being maximum. Now if you want to magnify this signal or want to see how does the signal look like, start decreasing the sweep width. We are slowly decreasing the sweep width, and this is what a signal looks like. Now the frequency, bring it back to 550 megahertz or center, so that we can come to know what is the exact frequency. Now as you can see, the exact frequency is 550 megahertz, and how exact it is, it depends on which point you have set. Now this point is precisely at the center of display, so the frequency is correct to the accuracy of 100 kilohertz. Now as you can see, the signal has been the scan width has been decreased to very less, less than even 100 kilohertz, and this is what a signal looks like. Now if the signal level is increased, you can see the signal level has been increased by 10 dB, again by 10 dB. Now there is a limit up to which the signal will be saturated and it will no longer appear to be increasing. Now this is the point where it is saturated. So after that, attenuator needs to be connected when the signal has been increased. Now as you can see, the signal has been increased much further, but it is still not being displayed. So what we can do is, we are providing two attenuators, 140 dB and 120 dB attenuator. So now we are putting a 20 dB attenuator here. So now you can see the signal level is now minus 57, minus 47, minus 37, minus 27, minus 7 dBm we are sending, and we have attenuated the signal by 20 dB. So right now it is displaying around minus 27 dBm of signal. If it can be decreased further with the help of a 40 dB attenuator. Now these are tight attenuators so that no leakage occurs. Now as you can see, the signal has come back to same, that is minus 57 dBm. So herein I have increased the signal by removing 4 attenuators, each of 10 dB, that is 40 dB, and again I have put a 40 dB attenuator, and the level remains the same. So this is how our input signal can be decreased with the help of these attenuators. Now the frequency response, if we want to see for this spectrum analyzer, what we can do is we can increase the scan width to the maximum so that we are able to see the entire spectrum from few megahertz to 550 megahertz. And now if we increase, if we change the center frequency, you can see we are changing the center frequency. Right now the displayed frequency is around say 330 megahertz, 320 megahertz, and it is constantly being decreased, and the accuracy is better than, I would say, plus minus 1 dB. The signal is not even attenuated. At this point it is attenuated, which is around 7 megahertz. So the specification 10 megahertz, this is the 10 megahertz to 550 megahertz, we have a accuracy of around